Hello, this is Mr. Gilmore with the 4.2 Tests for Parallels. Today we're going to be looking at what happens when a transversal cuts through lines. Now what we're also going to look at is the special angle relationships that are formed. We talked about these angle relationships back in 4.1. We saw corresponding angles, we saw alternate interior, alternate exterior, and also consecutive interior. We're going to see what does it mean to test lines to see if they're parallel. Think of it actually as some sort of test where you're applying some sort of application to a set of lines and actually determine whether or not those set of lines are actually parallel. Before we jump into our first test, I want to actually start by leading us into basically our first postulate of the chapter. So I want you to make a quick observation with me. Say, for example, that we have two lines, T and M, such that when T and M cross, there's some given angle measure between those two lines. So T and M form some angle. Now imagine then that you pick some sort of point other than the intersection point on where line M and T intersect, but let's say we pick some other point down here for another line to pass through. So now we've picked another point on line T, again, also not on line M. We don't want the same intersection. We have this second point on line T, distinct from the intersection of line T and M, and we call this line N. But it intersects, so N intersects T such that it measures the exact same angle as before. So thus, these two angles between M and N, that are formed by M and T and N and T, are the exact same measure. What then conjecture can we make about line M and line N? It would appear then that the only conjecture that we could actually make by them is actually that the two lines have to be parallel. So if those two angles, 1 and 2, so we have marked them down below. So here's the implication. If those two angles, 1 and 2, such they are corresponding angles, are equal, then what must follow? The two lines, M and N, must be parallel. It has to be, right? This is one of the kind of obvious assumptions we're making about this construction, which means we have a new postulate on our hands. We're calling this the corresponding angles postulate, or to us, CAP for short. Here's what the postulate says. If a transversal cuts a pair of lines and makes corresponding angles equal, then those lines are parallel. So whenever we come across a pair of equal corresponding angles, then the lines must be parallel. What we're going to lead this into then is looking at, are there other ways that we can test lines to be parallel? Here's a quick illustration of what we're saying with the corresponding angles postulate. We're given angle 1 and angle 2. Well, first of all, we're given that lines M and N are cut by a transversal T, which means they form angle 1 and angle 2. If we're also given that angle 1 and angle 2 are equal in measure, then line M and line N must be parallel to each other. So it's a test to see if lines are parallel. If we test the corresponding angles and it turns out the corresponding angles are equal, then of course we've got ourselves a set of parallel lines. Now we're going to see that there are 4 other ways that we can test to see if lines are parallel. And these are going to be theorems. We're going to prove that these tests are actually true. So corresponding angles postulate, right, that's the obvious one. The other ones are not as obvious, which means we need to test for parallelity to see if the two lines are in fact parallel. And we're going to see that they're also following our angle relationships, alternate interior, alternate exterior, consecutive interior. There's also a special case, the perpendicular transversal, meaning if a transversal cuts through two other lines and intersects both of them perpendicularly, then it turns out that those two lines have to be parallel. We'll see that special case at the very end. Let's jump into our very first test of the alternate interior angles test, or to us, the AIAT. What we're given is that we have a pair of alternate interior angles such that their measures are equal. What we can prove then is the lines then must be parallel. So if alternate interior angles are equal, then the lines are parallel. So down below, we're going to prove that line M and N are parallel based on angle 1 and angle 2 being alternate interior and angle 1 and angle 2 are equal. You'll also note that I strategically labeled a third angle, angle 3. We're going to see how angle 3 is used to help us prove that lines M and N are parallel. Now, since this is virtual and I'm doing video notes, I don't have an extra space for board, I've already included the proof of this on the next slide. Let's take a look. So the proof of AIAT. Same diagram, angle 1 and angle 2 are alternate interior angles. We've got angle 3 strategically labeled, and we're given that angle 1 and angle 2 are equal in measure. Let's see how this one unfolds. So we're given angle 1 and angle 2 are equal in measure. Well, angle 3 is in relationship to actually both our angle 1 and angle 2. If we look at angle 1, it's paired up as a vertical angle to angle 1, which means the measure of angle 1 is equal to the measure of angle 3 by the vertical angles theorem. And that also means that because of transitivity equality, or TOE, that the measure of angle 2 is equal to the measure of angle 3. Well, notice that angle 2 and angle 3 are both corresponding angles to each other, which means we now have a pair of equal corresponding angles. We can now call line M and line N parallel to each other by CAP, corresponding angles postulate. Let's take a look at our next test, the alternate exterior angles test. So it's going to be very similar to an alternate interior. We're given a pair of alternate exterior angles such that they are equal. We are then going to prove that the lines are parallel. So line M and line N, we will prove are parallel because we are given that angle 1 and angle 2 are alternate interior and they're equal in measure. Note that I've also strategically labeled angle 3 again. Let's take a look at its proof. The proof of AEAT, the alternate exterior angles theorem. So again, with angle 3 strategically labeled, it's in relationship to both angle 1 and angle 2. It's vertical angle to angle 1, and it's also corresponding angles to angle 2. Let's take a look at how this one unfolds. Alternate exterior angles, angle 1 and angle 2, are also equal. Measure angle 1 equals measure angle 2. Well, it's actually the exact same proof. The only detail we changed was that they're alternate exterior. The measure angle 1 equals measure angle 3 by vertical angles theorem. Thus, by transitivity equality, or TOE, that measure angle 2 is equal to measure angle 3. And then we can then follow, since we have an equal pair of corresponding angles, the lines M and N must be parallel by corresponding angles postulate. Now let's take a look at the consecutive interior angles test. This one's going to have a variation to the proof. It's not going to be quite the same as the ones we've just seen. So in this case, if a pair of consecutive interior angles are supplementary, then the lines are parallel. We're not looking for the consecutive interior to be equal. We want them to actually be supplementary because that's what's going to happen with a pair of consecutive interior. I've also strategically labeled an angle 3 in our diagram as well. So we're given that angle 1 and angle 2 are consecutive interior angles and that they're supplementary. We're going to prove that lines M and N are parallel. Again, angle 3 is labeled in such a way that it's in relationship to angle 1 and angle 2. Let's see how this proof unfolds. So the proof of the CIAT, the consecutive interior angles test. Well, with the given, we know that angle 1 and angle 2 are consecutive interior, and they're also supplementary, which means we know they add up to 180 degrees. But we can actually take advantage of knowing them supplementary, because angle 1 and angle 3 are also supplementary. Why? Because the linear pairs theorem. They form linear pair, which means by the linear pair theorem, angle 1 and angle 3 are supplementary. What then thus follows about angle 2 and angle 3? We'll take a look. From statement 1 to statement 2, angle 1 is supplementary to both angle 2 and angle 3, which means we have two angles supplementary to the same third angle. That's the same supplements theorem, SST, which means angle 2 and angle 3 are equal, again by the same supplements theorem, which means again by the corresponding angles postulate, angle 1 and angle 2 are an equal pair of corresponding angles, so thus line M and line N are parallel. Let's take a look at our special case. So if a transversal cuts perpendicularly to both lines, then we can say the lines are in fact parallel. So lines perpendicular to the same line are going to be parallel to each other. So in our given, we're given that T is both perpendicular to line M and line N. So line M and line N. We're going to prove that M and N are perpendicular to each other. And again, we're going to make use of the corresponding angles postulate. Let's take a look at this proof. So the proof of the PTT, the perpendicular transversal test. If line M is perpendicular to line T and line N is perpendicular to line T, then we can say something about angle 1 and angle 2 labeled in our diagram. Both angle 1 and angle 2 are right angles by the perpendicular lines theorem, something we proved back in chapter 2. That because the two lines there are perpendicular to the same third line, that means we know all the angles formed must be right angles. Well, we strategically labeled angle 1 and angle 2 because they are corresponding angles, which means I know the measure of angle 1 is equal to the measure of angle 2 by the right angle theorem, and that leads us to an equal pair of corresponding angles. So thus, line M and line N have to be parallel by the corresponding angles postulate. So this comes to the end of our lesson 4.2 on the tests for parallel lines. Be sure to be working on the 4.2 worksheet. If you do have any questions, please email me about that. With that, be good and do good.